Let's look at a problem that involves changing the order of integration of an iterated integral. We'll first take a look at region E and examine its projections on two of the coordinate planes. We could look at all three projections, but you'll see that two are similar. So first, we have E is the region such that x is between -1 and 1, y is between negative square root of 1 minus x squared and the square root of 1 minus x squared, and z is between x squared plus y squared and 1. So, we can express the iterated integral as the triple integral over the region E of f of x, y, z, dz, dy, dx. Since we want to first integrate over x, we must first determine the inequality that x must satisfy in terms of y and z. Notice that the region E is that of a paraboloid in the form z equals x squared plus y squared. So, for the projection onto the xy plane, we get a circular disk. Since x is bounded by the boundary of the paraboloid, x must be bounded by the boundary of the disk. So solving this equation for x, we can determine the bounds on x. Isolating x squared and then taking the square root of both sides, we get that x is equal to plus or minus the square root of z minus y squared. This means that x is between the negative square root of z minus y squared and the square root of z minus y squared. Next, we project the region onto the yz plane. The resulting shape is a parabola with an equation of the form y equals plus or minus the square root of z. We can use the graph to determine the limits on y and z. Notice that y is between the negative square root of z and the square root of z. Then, we can see that z is between 0 and 1. Finally, we can apply all of these limits to the iterated integral. That gives us the triple integral from z equals 0 to z equals 1, y equals the negative square root of z to the square root of z, x equals the negative square root of z minus y squared to the square root of z minus y squared of f of x, y, z, dx, dy, dz.